Welcome to Craft Guru Education. This is video number 2, Chemistry Form 4. Today we will cover what we have learned in video 1, recap the knowledge, talk about the electron configuration, followed by how to write formula for chemical compound. Let me share my screen now to show you the handout that I am using. For the purpose of recall back the knowledge that we have gone through, I will talk about atomic structure again. We learned that we have 3 subatomic particles in an atom. They are proton, the P represent positively charged. We have neutron, the N represent it is neutral in terms of charge, and electron, of course it is negatively charged, and E, the electron. Here's the electron configuration we discussed in video 1. Do you still remember what's the important thing we have to remember when we write electron configuration? The number of electrons that can sit in certain shell or orbit is determined by which number of shell. Shell number 1 maximum can fit in 2 electrons. Shell number 2 maximum can fit in 8 electrons. And shell number 3 maximum can fit in 8 electrons as well. Here we talk about the electron arrangement or electron configuration for hydrogen. He has 1 electron, therefore he has 1 electron valence at shell number 1. Followed by helium, he has 2 electrons, and it is just nice to fit in the first shell that can accommodate maximum 2 electrons. Next, we have lithium. The first shell has 2 electrons. The second shell has 1 electron. So the electron arrangement for lithium is 2.1, and so on. In the last video, I asked you to try writing the electron configuration for sodium and magnesium. Perhaps you have tried all until proton number 20. Let's see for sodium, 11 proton means it has 11 electrons. Here's the electron configuration. The first shell has 2 electrons, the second shell has 8, and the third shell has 1. This is the electron configuration for sodium, 2.8.1, and so on. Let's see for potassium. Potassium has 19 protons. Let's write the electron arrangement for potassium. The first shell has 2. So 19 minus 2 left 17. The second shell maximum can fit in 8. So 17 minus 8 has 9. That means the third shell can fit in another 8, leaving 1. So potassium has got 4 shells, 2.8.8.1. If you are interested, you can fill up the Google form in the description, and I will send you this handout. You can practice writing the electron configuration at home. Understand how electron configuration is being written is important for us to know how to write the ion of that element. Let's recap. Why element or metal want to have chemical reaction? Because they want to achieve stability. Starting from lithium, we ignore hydrogen and helium for now. Starting from helium, he has 1 electron valence. To achieve stability, he need to fill up the orbit or the shell. We also learned that he can either throw away 1 or add in 7. Of course, donating 1 electron is easier than taking 7. Here, when lithium want to go through chemical reaction, he will temporarily become Li. So, throw away 1 electron, meaning he has 1 extra positive. So, he become Li positive. Beryllium will become Be, 2 positive. And boron will become B, 3 positive. Can you try to write the ion for nitrogen, oxygen, and fluorine? You can pause the video and guess how to write for these 3 elements. Have you done writing the electron configuration for nitrogen, oxygen, and fluorine? Let's see. For nitrogen, it should be 2.5. Add together is 7. Oxygen 2.6. Fluorine 2.7. For nitrogen to become ion, it will turn to negative because nitrogen will receive 3 electrons, giving him 3 extra negative charge, and we write the ion like this, 3 minus. For oxygen is 2 minus, for fluorine is 1 negative. Same thing goes to sodium. Just now we saw the electron configuration for sodium is 2.8.1. For the third shelf, to become stable, it has to be 8. Either he throw away 1 or add 7 to achieve stabilization. Of course, again, throw away 1 is easier. Therefore, sodium, when it become ion, it turn into Na positive. Magnesium, 2.8.2, it will become Mg, 2 positive. And so on. If you wonder, how about potassium, who has 4 shells, 2.8.8.1? It's the same. If potassium throw away 1, the inner shell has achieved stabilization. So potassium will become positive, calcium will become 2 positive. Okay. This is the electron configuration. Understand electron configuration, you will understand how to write the ion. You know whether that element will become positively charged or negatively charged. So here I have prepared the table for you so that you can straight away refer to this table and learn to write the chemical formula for compound. Before I go into the chemical compound, let's look at the metal formed by what kind of element or compound first. First, let me clear the drawing on the screen. Next, let's look at metal. Metal basically is anything that has mass and occupies space. Metal can be either element or compound. What is element? Element is the particle formed from the same kind. For example, oxygen is O2. That means oxygen gas is formed by 1 oxygen atom and another oxygen atom. It is the same. So we call them element. How about compound? Compound formed by different elements. Example, water is H2O. Water is formed by 2 hydrogen and 1 oxygen. it has different element here. Has got hydrogen, has oxygen. Not like O2, it is the same element. So we call them element formed from the same species, compound, different species. We will look at element. What kind of element appear as atom? What kind of element appear as molecule? Atom, like I mentioned earlier, metal is like male, non-metal is like female. Male is very independent. They always go everywhere on their own. Female like to go together with another friend. For example, if we go toilet, we always call another friend to go with us. Or if we want to go to canteen to eat, we always call another friend to eat together. Just remember this example. Metal always do things alone. So metal appear as atom. Non-metal, they has to have a company. Therefore, in natural appearance, they always appear as molecule, either 2 or 3 together. Here we look at atom basically formed by metal. Any metal, they are atom, appear as a single particle. Sodium is metal. When we write the formula for sodium, we just write Na. Potassium is metal. When we write the formula for potassium, it's only K, 1%. Molecules normally are non-metal. They cannot exist as one single particle. They have to be together. For example, fluorine. When we write the formula for fluorine, we have to write Cl2. They have to have 2 atoms together. Oxygen, O2. What else? Fluorine, F2. And so on. Remember, non-metal appear as molecule, metal appear as atom, single person. When you write the formula for metal, just write the symbol will do. When you write the formula for non-metal, it has to have 2 or 3. 3, example, ozone. Ozone is O3. But of course, basically most of the non-metal formula is 2. Cl2, F2, O2, H2, and so on. This is element. For compound, same thing, molecule formed by non-metal. Just now I have given one example. Water is H2O. What other compound can you think of that is formed by non-metal? Maybe we learn in biology, we have glucose, C6H12O6. So this is molecule. How about ion? Ion is the combination between metal and non-metal. When they get married and achieve stabilization, in video 1, we talk about lithium 1 positive will attract fluorine 1 negative. So positive attract 1 negative, they become stable. But individually, they has charge, so they are ion. So ionic compound formed from metal and non-metal. The next part of this video, we will learn how to write chemical formula for ionic compound here. Alright, let me clear the screen and continue with how to write formula for ionic compound. This is the table I have prepared for you. If you want the handout, just fill up the Google form in the description and I shall send it to you. Here we have all these elements and their ionic formula. Positive ion, negative ion. Let's look at the first example. If potassium were to have chemical reaction with hydroxide ion. Example. Since potassium has one positive charge, hydroxide ion has one negative charge, so we only need one of each to become ionic compound. Potassium, one positive, the whole hydroxide, one negative. Therefore, when you write the ionic compound for potassium hydroxide, it is KOH. The challenge comes when the number of charge for positive and negative is not equal. Example, if I ask you to write the ionic compound for calcium fluoride, how would you write it? We know that calcium is 2 positive, fluoride is 1 negative. Calcium, 2 positive, fluoride, 1 negative. If fluoride has 1 negative, it is not enough to neutralize the 2 positive. If I draw the positive charge separately like this, you can see this fluoride 1 will neutralize 1 positive. We need another fluoride to neutralize another charge. You should be able to see how to write the formula now. We need 1 calcium and 2 fluoride. So this is the formula for calcium fluoride. CaF2. Another way to remember this easily is if we have Ca2 plus, F minus, you just cross the number to the bottom. Ca only need 1 and fluoride need 2. Write the 2 here. Let's see more example. If we want to write the formula for lithium carbonate, lithium 1 positive, carbonate 2 negative, lithium carbonate. If we use the shortcut method that I explained just now, cross the number, we have lithium 2 and we only need 1 CO3. This is how we write the formula. If you want to see the long explanation, Li 1 positive, CO3 2 negative. So we need 1 more Li to neutralize the positive. So we need 1 Li positive to neutralize this, another Li positive to neutralize this. And the formula is Li2CO3. Now, here people confuse about the 3. They thought it's CO3 like this. No. When we come to ionic compound or negative ion, either negative ion or positive ion, we imagine it is the whole thing. Example, we imagine, let me erase this. We imagine the whole CO3 is like this. Has got 2 negative. And then lithium, the whole thing like this, it has 1 positive. So when we need to have 2 lithium, we draw like this to neutralize the 2 negative of the CO3. This whole thing is 2 negative. Let's see one more example. Let me clear the board. And we get some complicated stuff for discussion. Here, aluminium thiosulfate. So let's do aluminium Al3+, and then this thiosulfate S2O32-. We simplify the explanation by using the shortcut. Just cross this number down to represent how many Al we need, how many thiosulfate we need. Here we need 2 Al, and we need this whole thing 3 times. Here we use a bracket to envelope them. S2O3, this is the whole thing. How many we need? We need 3. This is how we write the formula for aluminium thiosulfate. If you are interested, I can share with you this handout and you can practice all this compound. You can practice writing the chemical formula for all these ionic compounds, and we shall discuss about the answer later on. How do you find the chemical compound formula writing? It is that easy. Remember metal, non-metal, how many positive, how many negative. You need to balance the charges and then write the formula. Please like, follow, or subscribe and share our video. In video 3, I'm going to talk about how to write chemical equation. Do some revision on how to write ionic compound, and then writing chemical equation is not a problem at all.